All right, so today we're going to learn about end behavior of a polynomial. And like I said just a second ago, the only thing that matters is the leading coefficient. Okay, so we have a little chart here we're going to figure out. Hopefully we can kind of put all of this together. So starting off, if n is even, let's start with that. If n is even, what are our only two possibilities? If the degree, the exponent is even, what's our only two possibilities? Top, top, or bottom, bottom. So if it's positive, that's a top, top function. So you can fill in those arrows like so. If the degree, and you can see n is referring to the exponent, kind of like a little key up here, n. If the degree is negative, it's a bottom, bottom. Okay, now what is the most familiar? You've been doing it for 3 years. What's the most familiar even function that starts at the top and ends at the top, or starts at the bottom and ends at the bottom?
X.
Yeah, quadratic, right? Bless you. X squared. That's the most common one. And if you just remember that, you'll be good to go because they're all the same. It doesn't matter if it's an x to the 4th, an x to the 8th, an x to the 20th, an x to the 100th power. If a polynomial has a degree of 100, it's either going to start at the top and end at the top, or start at the bottom and end at the bottom. Okay? Odd is either, what positive, we're thinking what kind of slope? Yeah, up the mountain. Okay? So if it's positive slope, we're going to start at the bottom of the mountain and we're going to end at the top of the mountain. And if it's a negative slope, that means you're going down the ski slope, right? So we start at the top and end at the bottom. What is the most familiar odd function? You've been doing it for about 5 years, believe it or not. Zach?
Y equals mx plus b.
Yeah, a line. Y equals x. So y equals x squared is our most basic even function, and y equals x is our most basic odd function, a line. And we know the lines, if it starts at the bottom, where's it going to end? At the top. It has to, right? Now, some other stuff might happen, like an x cubed is odd, right? But it has the same end behavior as a line. So it might do a little curly Q in the middle, but it's still going to end up if it's positive. And it's still going to end down if it's negative. None of the stuff in the middle matters yet. Okay? Any questions on this? Do you remember this? Some of it? Good. Yeah.
What's your favorite, odd or even?
What's my favorite? Even. All right, so now we're going to do some more guesses, kind of like just what we did on our little investigation. So what is the leading coefficient of example 1? It is 2, but most importantly, what's important about 2? The fact that it's positive. That's really the important thing. The number 2 does not matter at all for end behavior, but the fact that it's positive is the main deal. And what is the degree? It is 3, but most importantly, what's important about that? It's odd.
It's on the bottom of the first page. But the word is in the back.
Oh, sorry, did it get slipped?
You can just rewrite it on the bottom.
Which means, which scenario is this? So it's odd, so you should be thinking about a line, right? If you ever see the word odd, or you see an odd degree, I want you to think, okay, what does a line do? It's either bottom, top, or top, bottom, okay? And this one is positive. So are we going up the mountain, or are we going down the mountain? Up the mountain. So it's going to start at the bottom, and it's going to end at the top. And I'm not going to do the writing and behavior. You don't need to do that. Okay, try to do example 2 on your own real quick. Go. Yeah. Okay, so what is the leading coefficient?
-2.
It is -2. Did you guys catch that? It's not in standard form. This would be the leading term because it's the largest exponent. So the leading coefficient is -2. Most importantly, it's negative. And the degree, the largest exponent is 4, but most importantly, it's even. Do what? So, think of anytime you see the word even, I want you to think of a quadratic. You're really familiar with quadratics now, the parabola shape, okay? So it's either top, or if it's negative, we know the quadratic is flipped upside down at the bottom. So this one is bottom. Reminds me of the minions. Bottom. We should, I agree. Ooh, yeah, I agree with that too.
Can we do that?
When we go backwards, always look at the always look at the x-intercepts first, okay? How many x-intercepts do we have on number 1? 3, which means your function should have 3 factors. The number of x-intercepts is the number of different factors you have. Notice I said different factors, okay? So what is this x-intercept right here? It's -4, which means inside the factor it had to have been the opposite. So this is x plus 4.
Does the order matter?
Nope. Okay. And this one here is -2, so what was the factor? X plus 2. And x minus 1. Now there is one more thing we need to note. What type of function end behavior does this have? It starts at the bottom and ends at the top, which means it's kind of an uphill motion, right? So is the coefficient positive or negative? It's positive, so we'll leave it as it is. If you remember from last class on Desmos, what did you do if you needed it to be upside down? Yeah, just tack a negative onto the very front. Okay, but we'll leave this one alone. Okay? So for example, that leads us to number 2. What is the only difference between number 1 and number 2?
Right before all the numbers, you put a little negative sign.
Exactly. Exact same intercepts, cross, right? We're just going to put a -1 in front. You don't even have to put the 1, you can just put the negative. But then all of the x-intercepts are the exact same, so the factors are the same as well. Okay? So that would be number 2. Exact same, the only difference is it's upside down. And you can see, kind of see how this kind of goes down the hill? That's a negative. Good. Let's look at let's do number 3. How many x-intercepts do we have? I only see 3.
Yeah, but it bounces.
Doesn't matter. How many x-intercepts do we have?
Oh my.
3. So we go y equals, and then 3 factors. Okay, what is this factor? X plus 4 would be the factor. But how many x plus 4s are there in order for it to bounce? So we will square it.
Is it wrong if you learn it twice?
That's not wrong. No, it's just I like to have the number of factors as the number of x-intercepts, so I can see they line up, and then I'll just square it to show it. And it's less to right, but. And this one is a cross or bounce. Cross or bounce. So there's just one of each of those. So x plus 2 and x minus 1.
Oh, so that's how you use that.
How many x-intercepts on number 4? Only 2. So x plus 4 and x plus 2, but they both bounce. So squared, bounce. And notice, what type of end behavior does this have? It's a top. And what is our degree? If we multiplied all of these factors out, how many x's would we have? X to the 4th, right? So it makes sense. It's even, so it's a top. That's on the recording. Okay, here we go, number 6. Number 6 is the doozy. Not hard, just long.
Oh my god.
Y equals, how many x-intercepts do we have?
A mini.
One's hiding. There's 4. You see the 6? It's way over there on the side.
Don't let her in.
There's 4. There's 4 x-intercepts, so we need 4 factors. Okay? And now we just go through. X minus 4 would be x plus 4. Does it bounce or cross? Square. X plus 2 crosses. X minus 3 bounces. And x minus 6 crosses.
That is many factors.
Now be careful, because usually you do all that and then you forget to do the negative in front. Is this a top or a bottom? Top. So we're good. We're done. But if all of this was upside down, like if this was a bounce this way and then a cross, and then a bounce, and then a cross,
Maybe bottom.
what would you have to do?
Negative.
You'd have to tack on a negative to the front. Number 5 is negative. Good. Because it's top, bottom. It's down the hill.
Well, it's number 3.
Number 3. Number 3 is negative. Down. Bottom. So we have our 4 x-intercepts. Next thing we need to determine, is this a top, or is it a bottom, or is it a bottom, top, bottom? And how do we figure that out? Because is this in standard form right now? No, it's not in standard form. That's what we learned last class. It's factored. It's been factored for us. How do you get it back to standard form? You'd have to multiply it out, right? Which is not going to be fun, right? Because you'd have to distribute the x through. Then you'd have negative x squared minus 3x, right? And then whatever that is, you're going to have to distribute through x plus 1. So then we have 4 things. And then we combine like terms, and then we have to multiply that by x minus 2. And then you have to FOIL all of those, right? It's going to take forever. You don't need to do all of that. All you need to do is circle the first thing in each factor. Because remember, the only thing that matters is the very first term. Nothing else matters. None of that tells us anything. All that matters is the very first term. And if we were to FOIL all of this out, the first of each factor is what gets multiplied for the first term. Does that make sense? So just multiply these 4 things together. And what would I get? Negative x to the 4th. Plus, ... don't care. So is this a bottom, or a top, or a top, or a bottom, top? It's a negative even function. So it's going to be a bottom. We are going to draw it. We're going to put it all together. And now we just have to determine, are we going to bounce or are we going to cross when we go on our little roller coaster ride? Do any of these bounce? No, they're all going to be cross. So let me get these x-intercepts back on here. We had 0, -3, -1, and +2. So we're going to go on our little roller coaster ride. We're going to cross, and you should end down. Your puzzle should go together. If you cross, and then there's nowhere to go and you end up, you know you did something wrong, because we know for sure that this is a bottom function.
I put it in the graph and it said at the top bottom function.
Nope, you didn't put it in right. We're not looking at the graph right. Do actually we'll skip that. Do example 5 on your own. A 0 is an x-intercept. So we have 3 of them. We have 2, 0. You can write them as points. I don't really care. -3, 0, and 4, 0, based on these factors. So I'll put those on my graph. 2, -3, oops, and +4.
Except for x.
So, how many x's do I have?